All right, ladies and gentlemen, so we had gone through the process, and again, we found the zeros for each factor, so that again, we plugged in -4 for x, and we were able to solve for a. So that's where we kind of left off before lunch. So now we're going to do the same thing, except now we're going to let x be equal to 3, and plug it back into our equation to help us solve for the other variable. Hey, Maddie. You want to come after school or in the morning? Yep. So again, I'm going to plug in 3 for x, so 5 times 3 minus 1 is equal to a times 3 minus 3 plus b times 3 plus 4. So notice what happens with 3 minus 3. 3 minus 3 is going to give you what? 0, so that'll go away. So 5 times 3 is 15. 15 minus 1 is 14 is equal to 3 plus 4 is 7. That gives me 7b. So what's b going to be equal to? b is equal to 2. So any questions on how I found b? So now remember, your final answer is going to be the 2 partial fractions. So now what you need to do is you need to plug in 3 for a and 2 for b. So my final answer is going to be 3 over x plus 4 plus 2 over x minus 3. That's your final answer. Hello?
What's my final answer?
You're it. All right? So now you can always check your answers. Remember, if you really wanted to, you can take your answers. What could you do with these 2 answers if you wanted to? You could take these 2 answers and do what? Add them together, and it should get you back to the original problem. If you look at the example we did that I had you practice adding these 2 rational expressions together, notice the answer we came up with, that's the original problem that I gave you. And notice these are the fractions that we added together. All right? Ooh, wow. Oh, wow. Isn't that exciting? Okay? All right. What is the purpose? Why am I torturing you like this? When you get to calculus next year, you are going to learn all kinds of calculus integration rules.
Hey.
So when you get to calculus, you're going to learn all these integration rules. You are not going to be able to integrate a large rational expression like the one I just gave you. You're not going to be able to do the calculus you need to do. However, you will be able to integrate these 2 simpler partial fractions in one step. So when you get to the integration of rational expressions in calculus, you have to perform this technique in order to do the calculus you need to. Because they want to be nice. They will in the beginning. All right, so let's take a look at another case. So another case is repeated linear factors. Now, before I go over this example here, I want to ask you a question. Last year, when you had to add fractions together, if you had, this is kind of a side note, if I asked you with a problem like this, what the LCD was, what would you tell me? Like if you wanted to add them, we're not going to add them together, I just want you to tell me what would the LCD be? 2x times x plus 1 squared. I agree with that. Suppose I give you another scenario. When I ask you for the LCD? 2x times x plus 1 squared. Same LCD, correct? But one problem had 2 fractions, the other problem had 3 fractions. Exactly. How do you know? So when you are doing your partial fraction decomposition, we know what the denominator is going to look like. However, we do not know if we have a 2 fraction or 3 fraction scenario. So you have to assume worst case scenario. What I mean by that is this. You have to be on the lookout that you're going to have 3 fractions. If this middle fraction does not exist, when you go to solve for the numerator, you get a 0. But you have to account for the fact that you could have a denominator. Again, this only comes up when you've got a repeated. What I mean by repeated is when you see the same factor. Remember what that square means. It means you have the same factor in the denominator twice. So when you go to set up example 2, repeated linear factors, again, they've already factored the denominator for you. We know one denominator is going to have our 2x. You have to consider that one fraction may have only one of the repeated factor, and then the last one will be your x plus 1 to the second. Now, when you are looking at the degree, you are looking just at the degree of the factor. When you look here, 2x, this is linear. You have an x to the first. So just like in the last example, what's the numerator going to look like? It's just going to be a constant, so we'll call that a. Here, you have an x plus 1. It's still linear. So this numerator is still going to be a constant. Now, yes, if you were to multiply and FOIL all this out, I agree with you 100% that the degree of this denominator is a quadratic. It's an x squared. But you're not looking at the degree of the denominator. You are looking at the degree of the factor. The factor is what? Linear. So then that means this numerator is going to be c. Okay? So you have 3 constants to solve for. Yes? Because you have an x plus 1 squared down here.
No, because you're looking for
You have the least common denominator. Again, something added together, somebody's denominator had to have that x plus 1 to the second. That's what makes it a common denominator. If you just added 2 fractions together, if it was just a 3 over 2x plus 5 over x plus 1, it's not going to have an LCD of x plus 1 to the second power. This LCD would just be a 2x, x plus 1. The only way you end up with an LCD of x plus 1, you have to have that square there. It's the only way you end up with that as part of an LCD. Okay? So now, just like we did before, what we have to do is we're going to clear the fraction out of the equation, multiply everything by your LCD. So we have 2x times x plus 1 to the second. So you always want to clear, once you set up the fractions that you're trying to solve for those numerators, we always want to clear them out. So when I multiply 4x squared minus 1 over the LCD, everything's going to cancel. I'm left with a 4x squared minus 1. Equals a times the 2x's cancel. I'm left with an x plus 1 to the second. B over x plus 1 times the LCD will leave me with a b times 2x times x plus 1. Plus c over x plus 1 to the second times the LCD will give me a c times 2x. Now, the only issue with repeated linear factors, yes, we're still going to find the zeros. We're going to let x be equal to the zeros. What are the zeros of each factor? The zero of each factors are what? -1 and 0. You are going to have to do a technique called equate like terms as well. And we'll go over that in a minute. The only case where you won't have to worry about this equating like terms is when you have the distinct linear factors, when all the factors are linear and they do not repeat. But let's just go ahead and let's let x be equal to 0 first. When I plug in 0, that's going to give me what on the left-hand side? That'll give you a -1. Well, 0 plus 1 squared is 1, and 1 times a is a. What happens when I plug in 0 here? Well, 2 times 0 is what? 0, and 0 times anything, all of this is going to go to what? 0. C times 2 times 0, this is also going to go to what? 0. So at least I know that a is equal to -1. So now let me plug in -1. So again, when I plug in -1, 4 times -1 squared is 4, minus 1 is 3, equals. What happens when I plug -1 in for x here? This -1 plus 1 is going to go to what? 0, and 0 times a is 0. What happens when I plug in -1 for x here? -1 plus 1, that's going to go to what? 0. 0 times all that goes to 0. So I have then, all I'm left with is c times 2 times -1. So 3 is equal to -2c, so what's c going to be equal to? -3 over 2. So any questions on how I found a and how I found c? This is what I mean that you're not going to be able to find everything just by using the zeros. The only case that works is when it's distinct linear. So this is where you're going to have to equate like terms. So the way you're going to have to equate your like terms is this. Going back to your original equation. You are going to have to multiply, FOIL, distribute, get rid of all your parentheses, multiply everything out on the right-hand side. So 4x squared minus 1 equals. X plus 1 to the second. Follow your order of operations. Got to deal with the exponent first. What is x plus 1 to the second when you multiply it out? That's going to give you what? X squared plus what? 2x plus 1. Now distribute the a. So we end up with ax squared plus 2ax plus a. So all I did here was I FOILed and I distributed. So I have 2b times x. You have to use your distributive property. 2b times x is going to give me what? 2b, x times x is what? X squared. 2b times x times 1 is a positive 2bx. And then finally, c times 2x is just plus 2cx. So all I've done is algebra. I've distributed. I've done some FOILing. So any questions on where I came up with this left-hand side from? Now, what makes a like term? Going back to Algebra 1, you've heard this phrase before. What makes like terms? Terms that have the same what? Terms that have what? The same variable with the same what? Exponent. Exactly. Same variable, same exponent. Remember, a and b and c are constants. Your variable is still x. So what I'm going to do, look at this equation that we have, as ugly as it is. Circle everything that has the largest power for x. So let's start with x squared. So I'm going to circle every term that has an x squared in it. So there's my 4x squared. Here's an ax squared. Here's a 2bx squared. So all of those terms have an x squared in it. And what I'm going to do is I'm going to set that equal. I'm going to write out a separate equation. It's taking my 4x squared, set it equal to ax squared plus 2bx squared. And if I need to, I would do that for my x to the first and do it for my constants if I need to, which I will when I get to this, a couple other examples. Now, you're not solving for x. So what can you divide out of this entire equation? You can divide out a what? X squared. So I can divide out an x squared. So that's going to leave me with 4 is equal to a plus 2b. What variable am I still trying to solve for? B. Do I know a? Yeah, I know a is equal to -1, so let's plug -1 in for a. So 4 is equal to -1 plus 2b. So what's b going to be equal to? B will be equal to what? 5/2. Remember I solved for it all the way back here when I let x be equal to 0? When I plugged it in at the very over here. Remember I plugged 0 back in? That was the first variable I solved for before I had to equate like terms. Okay. So notice that middle fraction did exist. All right. So now you have to write your answer. So now I'm going to plug -1 in for a. So I have -1 over 2x. Plus, I found b to be 5/2. So it's going to be 5/2 times x plus 1. Plus, what do we find c to be? C was -3/2. -3/2 times x plus 1 to the second. What kind of fractions are these right here? These are what? Complex fractions. How do you simplify complex fractions? You multiply everything by the denominator. So I multiply everything by a 2. So another way to look at this answer would be -1 over 2x plus 5/2 times x plus 1 minus 3/2 times x plus 1 squared. Those are equivalent answers. Because again, if you simplify a complex fraction, you multiply everything by 2 to simplify it. All right? You don't have to distribute the 2. You could if you wanted to in the denominator, but you could just leave it as 2 times x plus 1. You need to make sure, because again, if it's multiple choice, you're not going to see complex fractions written as your answer. You're going to see the complex fraction simplified. If it's free response, I won't care which form you leave it in. But again, like I said, multiple choice, you're not going to see it. You have to make sure you recognize your answer simplified. Yes, Emily?
Why do you only do the equate-like terms for the square?
Because as you saw from the beginning, when I found, because you have 3 variables to solve for, you only have 2 factors. You only have two factors. You only have two zeros there to look at. So what happens is it's not going to give you all the different variables. In the other case, you had just as many zeros as you did variables you're trying to solve for. So it worked. It gave you all of them. Okay? Because one of the factors has the same zero. Because x plus 1 squared and x plus 1 has the same zero. So it won't give you the everything. Okay? So any questions on the repeated linear factors? All right, let's look at another one. Before we do this example, jump back to Algebra 2 land, because you have to do this tonight for your homework. How do you factor x to the third minus 8? How do you do it? Do you remember? Cube, root, square, product, square, and don't forget the so. I just learned that song this year.
I don't know that's Miss French.
Yeah, that's apparently a Miss French song.
I just
No, it's not. She stole it.
So, first of all, guys, remember, SOAP stands for your signs. Same sign, opposite sign, always positive. So that helps you establish the sign pattern in your cube root. What's the cube root of x to the third? Cube root of x to the third is x. Cube root of 8 is 2. I see people on their phones. Put it away. Thank you. So there's the song cube root. Square. So square your first cube root, which is an x squared. Product. Multiply your two cube roots together. Square your last cube root, which is a 4. So cube root, square, product, square. And don't forget your SOAP. Because you have to factor the cubes tonight for homework, so I want to make sure you remembered how to do that. It's been a while. All right, are we good? But this problem's nice. They've already factored for you. So they've already done the factoring for you. So again, when you look at your denominators, one denominator will have a factor of x minus 1. The other one's going to have a factor of x squared plus x plus 1. Now, what makes this problem different than the other examples? Look at the denominator factor of x minus 1. This is still linear, correct? So to be proper, what's this numerator going to look like? It's going to be a constant, so it's going to be an a. Now, the second fraction, the factor is not linear, is it? It is a quadratic. So to be 1 degree less than 2 means the numerator could have an exponent with a degree of 1. Or it could also have a degree of what? Degree of 1 or a degree of 0. Exactly. So for example, would you agree with me that this would still be a proper fraction? Because there's a degree of the numerator less than degree of the denominator. Yes. Would you agree with me that this is a proper fraction? The degree of the numerator is less than the degree of the denominator. Would you agree with me that this is also a proper fraction? We don't know what scenario we have. We don't know. So you've got to consider worst case scenario. You've got to consider that you very well could have an x and a constant, or one or the other. So what would happen, let's suppose that you had this case. When you went to solve for this letter here, you would end up with a 0. If you have this case here, when you go to solve for the coefficient of x, you would get a 0. But you've got to consider worst case scenario that this could exist. So what happens is you're going to have a coefficient of x to try and solve for, as well as this constant. Don't use the same letter twice, so I'm going to write this as bx plus c. So we have a, b, and c we need to solve for. Again, anytime you've got a factor that's a quadratic, it's going to be that bx plus c scenario. Just like all the other examples, you're going to first clear the equation of the fractions. Multiply by the LCD. So we have x minus 1 times x squared plus x plus 1. So that's going to leave you with an x on the left equals a over x minus 1 times the LCD will leave you with a times x squared plus x plus 1 plus bx plus c over x squared plus x plus 1. The x squared plus x plus 1's cancel. That'll leave me with a bx plus c times x minus 1. you do have one linear factor. So because you have one linear factor, can you find 1, 0? So what is 1, 0 going to be? 1, 0 from your factor will be what when x is equal to what? 1. So when I plug 1 in for x, 1 is equal to a times 1 squared plus 1, which will give me a what? 3. Again, bx plus c, well, what happens when I plug 1 in here? 1 minus 1 will give me a what? 0. And 0 times anything is going to be what? 0. So what's a going to be equal to? A will be equal to what? 1/3. The only way you're going to be able to solve for b and c, you've got to go through that process of equating like terms. So again, we're going to equate the like terms. LT stands for like terms. So just like we had to do in the last example, you've got to distribute, FOIL, multiply everything out on the right-hand side. So I have my x equals. Distribute the a, ax squared plus ax plus a. So all I've done is I've distributed. Now I've got a FOIL. Bx times x gives me what? Bx squared. Bx times negative 1 is a minus bx. C times x is a cx. C times negative 1 is a minus c. All right, so now let me start with the largest exponent for x. In this entire equation, what's the largest exponent you see for x? X squared. So I'm going to circle everything with an x squared. But wait a minute, there's no x squared on the left. What am I going to set that equal to? 0x squared. So again, 0x squared is equal to ax squared plus bx squared. What can we divide out of everything? We can divide out of what? X squared. So 0 is equal to a plus b. Well, wait a minute, don't I know a? So a is a third. So 0 is equal to 1/3 plus b. What's b going to be equal to? Negative 1/3. Questions on how I found negative 1/3?
Did you get how'd you get like negative 1/3 to start? Or where'd you get the? You said let x be 1 and 1 equals a times 3. Where'd you get 3?
When I plug 1 into this original equation, 1 plus 1 plus 1. So you just plug 1 back into this whole entire original equation.
Where'd you get the 1?
Your 0. Remember your factor? You've let yours.
Oh, okay, I see. Oh, okay, I see.
So we equated my quadratic. After x squared comes a what? X. So I'm going to equate everything that has an x with it. So I'm going to use a different shape. I'll use a triangle. I'm going to put a triangle around every term that has an x in it. So I've got x on the left, ax on the right. I've got a minus bx and a plus cx. So now I'm going to do the same exact thing. I'm going to equate all my terms that have an x. So x is equal to ax minus bx plus cx. And again, what can you divide out of everything? You can divide out of what? X. So 1 is equal to a minus b plus c. Well, don't I know a? Don't I know a? Don't I know b? So can I use that to find c? Yes. So 1 is equal to 1/3 minus negative 1/3 plus c. So what is 1/3 minus negative 1/3? 2/3 plus c. So what's c going to be equal to? What's 1 minus 2/3? 1/3. If you needed to, you could finish and equate the constants as well. But we found everything we need. We found A, we found B, and we found C. So any questions on how I found A, B, or C? Like I said, you are going to have to equate like terms in every single case except for the very first case when you have distinct linears. All right? Anything else, you're going to have to equate the like terms. So now remember, I'm going to plug these values into my fraction. So A was 1/3. So my final answer will be 1/3 plus B, which is negative 1/3. Oh, this is 1/3 over x minus 1. Negative 1/3 x plus 1/3 over x squared plus x plus 1. If I simplify my complex fraction, I'm going to multiply everything by what? Multiply everything by 3. So multiply this by 3, this by 3. So I end up with 1/3 times x minus 1 plus negative x plus 1 all over 3 times x squared plus x plus 1. Remember, these are equivalent. Yes, Gracie?
Should we simplify or do we never simplify?
If it's free response, but I'll tell you right now in the multiple choice, you'll never see the complex fractions. So you better know what your answer matches up to. All right, that's why I'm writing it both ways for you, because on multiple choice, they'll always be simplified all the way. All right, any questions on example 3? So this is, again, when you have a linear and a quadratic. Like I said, as long as one factor is linear, you can start using one of the zeros to get you started. But if you do not have any linear factors, that method's out the door. You've got to go jumping right to equating like terms. You have no choice. All right, so for example, let's take a look at when you have repeated quadratic. We did repeated linear. Same idea. You have a denominator of x squared plus 4 to the second. So one fraction will have x squared plus 4. The other one will be x squared plus 4 to the second power. So this denominator has a quadratic factor. So what does that mean about the numerator? The numerator could be linear, it could be constant, or it could have both. So you've got to consider, like we just did in the last example, you've got to consider the x and the constant. So I'm going to set this up as ax plus b. This denominator also has a quadratic factor. Don't repeat the same letter. So same thing, you've got to consider an x and a constant in the numerator. So I'll write this as a cx plus d. Yes, Jason?
So why do you need to do the first one that isn't squared and then the one that is squared?
Again, if I add these two together, one of the fractions has just one of the factors. Because again, we're assuming that, again, you wouldn't make both of these squares, because they would already be combined into one fraction anyway. The answer is the result I would get with my partial fractions in the end would have the x squared plus 4 to the second already added together. Okay, does that make sense? So you want the denominators to always be different. Just like I've done in all the other examples, how am I going to start this? Multiply everything by my LCD. So all of them, you're always going to clear the fractions out of the equation. So always multiply by the LCD once you get your setup. So on the left, I'm going to have a 2x squared plus x plus 8 equals. Only one of the x squared plus 4s will cancel, so I'm going to be left with an ax plus b times x squared plus 4. X squared plus 4 to the second, they're both going to cancel. I'm just going to be left with a cx plus d. So even if you try to find a 0, there are no zeros for x squared plus 4 that are real. They're imaginary. So you have no choice but to start with equating like terms. So again, just like what I do, you want to FOIL these two binomials together. What is ax times x squared? Ax cubed. Ax times 4 will give me a 4ax. B times x squared will give me a bx squared. And then finally, my b times 4 will give me a 4b. Okay, so all I did was FOIL. We good? So now, let's start equating the like terms. What's the largest exponent you see for x? The largest exponent is x cubed. Is there an x to the cubed on the left? No, so what am I going to set ax cubed equal to? 0x cubed. So 0x cubed equals ax cubed. So what's a going to be equal to? A is equal to 0. So what that tells you in this first fraction, there's not going to be that x up there. You're only going to have a constant. So after x to the third comes what? X squared. So I'm going to go ahead and put a square around everything that has an x squared. Is that it? Yeah. So next I'm going to take my 2x squared, set it equal to bx squared. So what's b going to be equal to? B will be equal to 2. So after x squared comes a what? X. So I'm going to go ahead and put a triangle around everything that has an x. So I've got an x on the left, 4ax on the right, and a cx on the right. So then x is going to be equal to 4ax plus cx. So what can I divide out of everything? I can divide out of what? X. So 1 is equal to 4a plus c. Well, what do I know about a? A is equal to what? What's a equal to? 0. So then what's c going to be equal to? 1. So last but not least are my constants. Nothing that has an x in them. So I have an 8. I'm just going to double underline. So I'm going to underline everything that does not have an x. So I've got a 4b plus d. So 8 is equal to 4b plus d. Well, what is b equal to? B is equal to what? 2. So 8 is equal to 4 times 2 plus d. So what's d going to be equal to? 0. So what that tells me, in the second fraction, I'm just going to have an x in the numerator. There is no plus d up there. Any questions on how I found a, b, c, or d? So now I can write my answer. Remember, a is 0. So the only thing in the numerator of this first fraction is going to be the 2. So I have 2 over x squared plus 4. Plus, in my second fraction, c is 1, so I have a 1x. D is 0. So it's going to be x over x squared plus 4 to the second. Again, can you always check your answer if you want to? Yes. What would you just simply add your answers together and see if it got you back to the original? So any questions? So these are the cases you have to be familiar with. Again, we're not going any higher than quad. I mean, you could do the same thing if you end up with cubes, wherever. The only highest we're going to go is quadratic factors. All right. Any questions on example 4? So every case I gave you so far were proper fractions. Take a look at the last and final example. How come this last example is improper? Degree of the numerator is a 3, degree of the denominator is a 2. So the only thing, partial fraction decomposition does not work on improper fractions. So you have to make this proper by dividing. Would synthetic division work here? No. So you have no choice but to use what? So before you can do your partial fraction decomposition, you have to make your fraction proper if it's improper. So you have to do your long division. So x squared plus x, remember the way long division works, we're going to take the x squared plus x minus 2, divide it into x to the third. Depending upon how you were taught long division, I would put a placeholder of 0x squared minus x plus 3. So how do we start this? You have no idea? You take x squared and you divide it into what? X to the third. So x to the third divided by x squared will give you a what? X. And I always keep my like terms lined up. That's the trick of long division, keep your like terms lined up. After you divide, what do you do next? Do you remember? Multiply. So x times x squared is x to the third. X times x is x squared. X times negative 2 is a minus 2x. Remember in long division, after you multiply, what comes next? You distribute the negatives and you're going to subtract. So x to the third minus x to the third cancels. 0x squared minus x squared is a negative x squared. Negative x plus 2x is a positive x. And then bring down your plus 3. Can you go again? Can you take x squared and divide it into negative x squared evenly? Well, that's going to leave me with a minus 1. Multiply negative 1 times x squared is negative x squared. Negative 1 times x is a negative x. Negative 1 times negative 2 is a positive 2. And again, what do you have to do here? You're going to end up doing what? Subtracting. What happens when you subtract a negative? It becomes a positive. So the minus x squared and x squared goes away. X plus x is a 2x. 3 plus negative 2 is a plus 1. Can I go again? No, because I can't take x squared and divide it into 2x evenly. So what is this 2x plus 1? This is your what? Remainder. So remember how you write your remainder when you are dealing with your division. You take your x minus 1 plus you take your remainder of 2x plus 1, place it over the divisor. So now look at your fraction that you created. Is this a proper fraction? Yes. So now this fraction is proper. Now you can do your partial fraction decomposition on the remainder. This x minus 1, he's just going to tag along to your final answer. You just have to remember to include that x minus 1 as a part of your final answer. So now what you have to do is you're going to break up this fraction, the 2x plus 1, over. Can you factor x squared plus x minus 2? Yeah, factors into x what? And x minus 1. So now that you've factored the denominator, you can see what the setup of the two partial fractions are going to be. One denominator will be x plus 2. The other one will be x minus 1. Tell me what we know now about those numerators. Those numerators are going to be in the form of what? Constant. So I'll call this one A, this one B. So what scenario do I have here? I've got both of my factors are linear, and they're different, don't I? This is my good news scenario. Why is it my good news scenario? Because do I have to worry about equating like terms? Nope. No. So you guys go ahead and finish this one for me. Go ahead and find A and B for me. So we all come up with 1 for A and 1 for B. Okay? So that your final answer, don't forget about that x minus 1. That x minus 1 has got to be a part of your answer. and then 1 over x plus 2 plus 1 over x minus 1. All right? Again, the only time, this is the only case where you don't have to worry about equating like terms, is when you have those distinct linear factors. Otherwise, you've got to worry about the equating like terms. All right? Okay, so that is it